In this video, we'll go through exam questions that cover the criteria calculated using compound measures, including speed, density, and rates of pay. You can locate the questions on the mathsmath.com website under Level 2. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here's the first one. A woman needs to work out how long it will take to drive to York. She checks the journey on the website. The distance from her house to York is 80 miles. 20 miles of the journey are through roadworks with a speed restriction of 40 miles per hour. She should drive the rest of the journey at an average speed of 50 miles per hour. How long should the journey take? Show your working. So this is about speed. We've got distance, we've got time, we've got speed. So the first thing to do is to write the speed formula. If you don't remember it by heart, think of how do we describe speed. So I can say the speed on a road is 20 miles per hour. So miles, that's the distance. Hour, that's time. And we've got the fraction line here as well. So the formula for speed is distance over time. Sometimes you'll see a triangle being used like this. So S, D, T. To find S, you divide D by T. To find T, you divide D by S. To find D, you multiply S by T. So what do we know? We know the speed, 40 miles per hour. Distance is 20 miles. We don't know the time. And what did we say here? To work out time, we do distance divided by speed. So T is equal to 20 divided by 40. Now 20 is half of 40, so this is 0.5. 0.5 hours, because we've input 40 miles per hour. So 20 miles and time will be in hours. That's why 0.5 hours, which is 30 minutes. That's for the first part of the journey. What about the second part? Because we've done 20 miles, so this one will be 60 miles. 80 take away 20 gives us 60. That's why 60 miles. 60 miles is done at an average speed of 50 miles per hour. So we'll repeat this process. So we'll say 50 miles per hour is equal to 60 divided by T. So T is equal to 60 divided by 50, which is the same as 6 divided by 5. So 6 divided by 5. How many 5s fit into 6? That's 1, and we have 1 remaining. We've run out of digits, so we're going to put decimal point here and in the answer as well. And we can add zeros. How many 5s into 10? That is exactly 2. So 1.2 hours. 1.2. 1, we know that's 1 hour, so that's going to mean 60 minutes. What about the 0.2, 0.2 hours? What is that in minutes? Well, we know that 0.1 is the same as 10%. So 10% of 60 is equal to 6. So 0.1 will be 6 minutes. 0.2 will be 12 minutes. So 60 minutes is 1 hour. 30 and 12 gives us 42. So 1 hour and 42 minutes for the total journey. You are planning the delivery of furniture to 2 customers. you expect that you will drive at an average speed of 50 miles per hour. Unloading each delivery will take 30 minutes. This is the route you take. You leave the depot at 8 a.m. What time would you return to the depot if everything went to plan? Show your working out and write the answer in the box below. So starting from the depot, we'll go to delivery 1, and that is 55 miles at 50 miles per hour. So writing the formula, speed is equal to distance over time. I'll do the triangle as well. So what do we know? We know the speed, which is 50 miles per hour, and that's equal to distance, which is 55 miles, but we don't know the time. So time will be equal to 55 divided by 50. Remember, to work out time, we do distance divided by speed. So this line here is like a fraction line where you divide, and here you multiply across. So 55 divided by 50. We can divide both numbers by 5 to simplify the fraction. That gives us 11 over 10. 11 divided by 10, we know that it is 1.1. So moving a decimal point one place to the left to make this number smaller. So that is 1.1 hours. 1 hour, we know that is 60 minutes. 0.1 of an hour, as we discussed in the previous question, that is 6 minutes. It's like 10% of an hour, so dividing 60 by 10 gives us 6 minutes. So in total, this is 66 minutes. Unloading each delivery will take 30 minutes, so we're going to need to add 30 minutes here. And here. And from delivery 1 to delivery 2, how long does the route take? So we've got 110 miles at 50 miles per hour. So repeating this process, we're going to do 50 is equal to 110 divided by t. So 50 is the speed and 110 is the distance. So to work out the time, we will do distance, which is 110 divided by 50. Both numbers can be divided by 10, so this would give us 11 divided by 5. So 11 divided by 5, how many 5s fit into 11? That's 2, and we have 1 remaining. We're finished with the digits, so put decimal point here, and we can add zeros. So how many 5s into 10 now? That's exactly 2, so 2.2. So that is 2 hours, which is 120 minutes, and 0.2 of an hour. 0.1 was 6 minutes, so 0.2 is going to be 12 minutes. So in total, this is 0 and 2 is 2, 2 and 1 is 3, 132 minutes for this second part of the journey. Or this could just be 2 hours and 12 minutes, and the first part would be 1 hour and 6 minutes. So now we've got 30 minutes here and 30 minutes here, so we need to add an hour. So you leave the depot at 8 a.m. So adding this 1 hour, that will bring it to 9 a.m. Then we'll need to add the hours 1 and 2, that is 3 hours. So 9 and 3, that gives us 12. So 12 p.m. And then we have 12 minutes and 6 minutes, that is 18 minutes. So that's going to be 12:18 p.m. Lisa has to drive 50 miles to the market. The market starts at 9 a.m. She needs to arrive at least half an hour before the market starts. She leaves home at 7:10 a.m. Lisa says, if I drive at an average of 40 miles per hour, I'll be there in time. Is she correct? You must show your working. So again, we've got to use the speed formula. What we know is the speed. We also know the distance. We don't know how long it will take. So again, to work out time, we'll do distance divided by speed. So time is equal to the distance, which is 50 miles, and the speed is 40 miles per hour. We can simplify the fraction here by dividing by 10, so we get 5 divided by 4. So 5 quarters, that is 1.25. But if you don't know that by heart, you can just go and divide 5 by 4. So how many 4s fit into 5? That's just 1, and we have 1 remaining. Finished with the digits, so put a decimal point here and add a 0. So how many 4s into 10? That is 2 of them, because 2 times 4 is 8, so we have 2 remaining. Now we add another 0, so how many 4s into 20? That is exactly 5. So 1.25 hours. So 1 hour, we know that is 60 minutes. And 0.25 of an hour, that is a quarter of an hour, which is 15 minutes. So 1 hour and 15 minutes. So if she leaves home at 7:10, adding 1 hour, that will take it to 8:10 a.m. Adding 15 minutes, that will take it to 8:25 a.m. And the market starts at 9 a.m. and she needs to be there half an hour before, so that would be 8:30 a.m. So this is 5 minutes early. So she's correct. So we're going to say, yes, Lisa is correct. Now we move into the calculated questions. Jack is a jeweler. He makes a pendant in the shape of a triangle prism as shown in the diagram. Jack makes the pendant from solid gold. He uses this formula. V is equal to T times L, where V is the volume of a triangular prism in cubic centimeters, T is the area of the triangle face in square centimeters, and L is the length of the prism in centimeters. Jack knows that mass is equal to density times volume. The density of gold is 19 grams per cubic centimeter. The cost of 1 gram of gold is £40. Jack sells the pendant for £382 more than the total cost of the gold needed to make the pendant. How much does Jack sell the pendant for? So the price will depend on the mass and the density. So we've got to use the formula. So to work out the mass, we'll multiply density by volume. Density we know, but we don't know the volume. So we're going to work out the volume first. So V is equal to T times L. T is the area of the triangular face. So that's this one here. And the area of a triangle is base times height divided by 2. So base is 1 centimeter. Height is 3 centimeters. So 1 times 3 divided by 2. 1 times 3 is 3 divided by 2. That gives us 1.5. So that's the area of the triangle prism. And we're going to multiply it by the length, which is 4 centimeters. So 1.5 times 4, which is equal to 6. So V is equal to 6 cubic centimeters. The mass is density, which is 19, times the volume, which is 6. So 19 times 6 gives us 114 grams, that is. So the cost of 1 gram of gold is £40. So we're going to do 40 times 114, which is 4,560. So that's the total cost. He will sell it for £382 more. So we're going to do 4,560 plus 382. So that is 14. And you can double check with a calculator. And that is £4,942. Nicola wants to put a flat roof on a bike store. The roof will be made of concrete in the shape of a cuboid as shown. Nicola wants to put the metal strip along 2 of the longest edges of the roof. She knows the density of concrete is 2,300 kilograms per cubic meter. The mass of 1 meter of metal strip is 5 kilograms. Work out the total mass of the concrete and the strips she wants. So we've got to work out the total mass of the concrete and the strips that she wants. So let's start with the mass of the concrete. We know the density, but we don't know the mass. So we've got the formula here, which is density is equal to mass divided by volume. So similar to previous questions that related to speed, we can just write this as D is equal to M divided by V. Some people use don't move Vera as a way to remember. So we've got D is equal to M divided by V. So I'm going to write it in the shape of a triangle, just like we did before with speed. So we know the density, 2,300. Do we know the mass? No, we don't. Do we know the volume? We don't, but we can work it out. So we've got the dimensions, 2 meters, 3.5 meters, and 12 centimeters. As we're given the density in cubic meters, we're going to stick to meters. So we can keep the 2, we can keep the 3.5, but 12 centimeters will need to be converted to meters. So in 1 meter, we know there are 100 centimeters. So this will be 0.12 meters. If you divide 12 by 100, it gives you 0.12. So to get the volume, we're going to do 2 times 3.5 times 0.12. Which is 0.84. So we're looking to work out the mass, and as you can see, mass is here, so mass is equal to D times V. So mass is equal to 2,300 times 0.84. So we get 1,932 kilograms, because we input kilograms per cubic meter. So that's the mass of the concrete. We don't know the mass of the strips though. We're given that the mass of 1 meter of metal strip is 5 kilograms. So she will put that along 2 of the longest edges of the roof. The longest edge is 3.5 meters. So that's going to go here and here. So 3.5 and 3.5, that is going to be 7. So 7 meters. 1 meter weighs 5 kilograms. So 7 times 5 gives us 35 kilograms. So we're going to add it to 1,932, and that gives us 1,967 kilograms. At 20:40, a witness saw the suspect entering the park at gate A. Another witness saw the same person leaving the park through gate B exactly 12 minutes later. The group are given this map of the park. The map has a scale of 1 to 25,000. The distance between gates A and B on the map is 9 centimeters. What was the average speed of the person seen entering and leaving the park? Give your answer in meters per second. So we're working out the speed. Speed is distance over time. So what is the distance? On the map this is 9 centimeters, but the scale is 1 to 25,000. So what we're going to do is 9 times 25,000 to work out in reality this distance. Which is 225,000 centimeters, that is, because we input centimeters. We've got to give our answer in meters per second, so we've got to convert this into meters. In 1 meter, there are 100 centimeters. So in 225,000 centimeters, how many meters are there? We're going to divide this by 100, and it gives us 2,250 meters. So we've got the distance, which is 2,250 meters. Now we need to enter the time, and we got to say it in seconds. We know that it took the person 12 minutes, but we need to give our answer in seconds. So 12 minutes, 60 seconds in each minute. So we're going to do 12 times 60, which is 720. So 2,250 divided by 720 gives us 3.125. And that's the speed. So 3.125 meters per second. Kamal wants to reduce the amount of water he uses at home. He uses the kitchen tap for 350 days a year for 20 minutes each day. The flow rate of his kitchen tap is 5.5 liters per minute. Kamal wants a new kitchen tap with a flow rate of 4.7 liters per minute. He thinks he can save more than 6,000 liters of water in a year if he uses the new kitchen tap for 350 days a year for 20 minutes each day. Is Kamal correct? Show how you decide. So we're working with the flow rate, but do we know how to work out the flow rate? This here, 5.5 liters per minute, tells us how to do it. Liters per minute. So that is equal to 5.5. This is going to help us work out how many liters he uses in total, because we don't know that. So liters, which we need to work out, divided by minutes, that's 20 minutes per day, is equal to 5.5. So you see how this has formed a triangle as well. L, got the 20 here and the 5.5. So to work out L, we're going to do 20 times 5.5. L is the number of liters, as we said. So L, 20 times 5.5 gives us 110 liters per day. It's 350 days, so we're going to do 110 times 350. So that gives us per year how many liters he uses. Which is 38,500 liters. Let's repeat this process now with a new flow rate. So we've got L, which we're going to work out, number of liters. We've got 20 minutes still, and the new flow rate, that is 4.7 liters per minute. So to work out L, we will do 20 times 4.7, which is 94. So that's the number of liters per day. Multiplying that by 350 should give us for the whole year, which is 32,900. Okay, so he thinks the difference will be more than 6,000 liters of water. So let's do 38,500, take away 32,900. and that is 5,600. So that is not more than 6,000. We're going to say no, it's 5,600 liters. A fisherman sets off from Dunsey in a boat. His boat will travel at an average speed of 5 kilometers per hour. He has this map so that he can avoid the rocks. He needs to meet up with the ship at coordinate L34 at 5 p.m. He needs to know at what time he must leave Dunsey. At what time must he leave Dunsey? So we're starting from Dunsey. And he meets up with a ship at coordinate L34. So there is L and there is 34. So going down to this point here. He needs to avoid the rocks. So the journey could be going like this. We've got a scale which is 1 to 25,000. So how many centimeters is this first of all? So we've got a scale which shows us that this is 1 centimeter. So this one will be 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 centimeters. And we have a scale of 1 to 25,000. So we're going to multiply 15 by 25,000 to work out the number of centimeters in reality. Which is 375,000 centimeters. So the boat will travel at an average speed of 5 kilometers per hour. So let's just work this out in kilometers. So we've got it in centimeters, 375,000 centimeters. If we convert it into meters first, so dividing this by 100 to get the centimeters, so we get 3,750 meters. Now, in 1 kilometer, there are 1,000 meters. So we're going to divide this by 1,000, which gives us 3.75 kilometers. So the speed is 5 kilometers per hour. And this is the distance. So 5 kilometers is 1 hour or 60 minutes. This is less than 5 kilometers. It's 3.75 kilometers. So how many minutes will that take? Okay, so what do we multiply 5 by to get to 3.75? So we can do 3.75 divided by 5, which is 0.75. So we'll do the same on the other side. So 0.75 times 60, which is 45. So it will take 45 minutes. So he must leave 45 minutes before 5 p.m. So that's going to be 4:15. Or 15 minutes past 4. An architect designs a shop refit. The architect needs to work out the weight of an oak panel. The oak panel measures 0.06 meters by 0.9 meters by 1.5 meters. The density of oak is 700 kilograms per cubic meter. What is the weight of the oak panel in kilograms? Show your working. So weight, that is mass, means the same thing. So we've got density and mass, so we need the density formula. Don't move Vera, as is said. So density is equal to m divided by v. Do we know the density? Yes, it's 700 kilograms per cubic meter. So 700. Do we know the mass? No, we don't. We need it in kilograms. And the volume, we don't know, but we can work it out because we've got the dimensions. And they're all in meters as we need them. So all we need to do there is 0.06 times 0.9 times 1.5, which is 0.081. So again, working with a triangle, we working out the mass, which is at the top. So mass is equal to D times V. D is equal to 700 and V is equal to 0.081. So multiplying 0.081 by 700 gives us 56.7. So 56.7 kilograms is the mass. Speed is equal to distance divided by time. Calculate the speed when the distance is 15.8 miles and time is 2.4 hours. Round your answer to 2 decimal places. Show your working out and write the answer in the box below. So here we've been given the formula. We've got to work out the speed when we know that the distance is 15.8 and the time is 2.4. We've got to work with miles and hours. So using a calculator, 15.8 divided by 2.4 gives us 6.58333. So 3 is recurring. We've got to give our answer to 2 decimal places, so that's 1, 2. This will be the cutoff point. Looking on the right, we've got a 3, which means we round down, so we keep this as an 8, 5 and a 6. So 6.58 miles per hour. The manager has 4 houses to look at today, A, B, C and D. This is a sketch showing the manager's office, the houses and the distance between them. Speed is equal to distance divided by time. The manager will leave his office at 10 a.m. and travel to each house once only, and then return to his office. He will spend 20 minutes at each house. His average speed on the main roads is 70 kilometers per hour. His average speed on the minor roads is 40 kilometers per hour. He can visit the houses in any order. What time will the manager be back at his office? Show your working out and write the answer in the box below. Okay, so we'll start at the office. As he can visit the houses in any order, I'm going to suggest go to A first, and then B, and then D, C, and then back to the office. At each house he will stay for 20 minutes, so 20 minutes here. Let's start from the office to A. That is 42 kilometers. That's on the main road. As you can see, the arrows are in bold. So actually what we can do is work it out from the office to A, B and D, because these are main roads. So we can add 42 and 35 and 56. So that gives us the total distance on the main road. Which is 133 kilometers. We know the speed is 70 kilometers per hour for the main roads. So S is equal to distance divided by time. So we know the speed is equal to 70 kilometers per hour. Distance is 133 kilometers. We don't know how long it's going to take. So again, to work out the time, we'll do distance divided by the speed. Distance is 133, speed is 70. So 133 divided by 70 gives us 1.9 hours. In 1 hour there are 60 minutes, so if I multiply this by 60, it gives us 114 minutes. Now we'll repeat this for the minor roads. We've got 27 kilometers and 39. Which is 66. So to work out the time it takes to do the minor roads, we'll do distance, which is 66, divided by the speed, which is 40 kilometers per hour. So 66 divided by 40 gives us 1.65. To work it out in minutes, because this is in hours, we'll multiply it by 60. So it gives us 99 minutes. So for the main roads, 114 minutes. If I take away 60, which is 1 hour, we get 1 hour and 54 minutes. 99 minutes. If I take away 60, it gives me 39. So 1 hour and 39 minutes. That is for the minor roads. We also have the 20 and 20 and 20 minutes and another 20. So that is 60 and 20, 80. So 1 hour and 20 minutes. So we can add these 3 to 10 a.m. So 10 a.m. if I add 1, 2, 3 hours, that is going to take me to 1 p.m. So now 39 minutes and 20 minutes, that is 59 minutes. So 1 minute shy of 1 hour. So if I borrow 1 minute from the 54, I can make 1 hour there. So this becomes 2 p.m. and I add 53 minutes as well. 2:53 p.m. So he will be back at 2:53 p.m. Amy wants to catch the 10:12 a.m. train from Darlington to Chesterfield. She needs to allow 10 minutes to buy a ticket and get to the platform. She lives 2 miles from the station and knows that she can walk at 3 miles per hour. At what time should she leave home? Show your calculations and the workings out in the space below. So we're working with speed, so we need the formula. Speed is equal to distance over time. We know the speed is equal to 3. Do we know the distance? Yes, that is 2 miles. But we don't know how long that will take, so we don't know the time. So time is equal to 2 divided by 3. Or distance divided by speed. 2 divided by 3 gives us 0.67. I've rounded that to 2 decimal places. But I don't even need to do that, in fact, because it tells us that this is 2/3 of an hour. 2/3 of an hour, that is 40 minutes. Because a third is 20, 2/3 is 40. So this is 40 minutes. So it takes 40 minutes to get there, and she needs to allow 10 minutes to buy the ticket. So that is 50 minutes in total. And she needs to catch the 10:12 a.m. train. So we're going to go backwards by 50 minutes. So what I'm going to do, I'm going to go backwards by 60 minutes and then give 10 minutes back. So if I go backwards by 60 minutes, I'll go to 9:12 a.m. Now I need to give the 10 minutes back to this, so I'm going to add 10 minutes. So that will be 9:22 a.m. You could also break down the 50 minutes into 12 minutes and 38 minutes. So going backwards by 12 minutes will take you to 10 a.m. and then take away another 38 minutes and it takes you to 9:22 a.m. Steph supports Leicester City Football Club. She and 3 friends are going to watch the team play at West Ham United. The table shows information about the 3 parts of their journey. Drive 108 miles, average speed 48 miles per hour, train maximum 34 minutes, walk to stadium maximum 25 minutes. What is the latest time they can leave to be sure of getting to the stadium by 2:30 p.m? You must show your working. Okay, let's work out how long this will take. So we're using the speed formula. We know the speed is 48 miles per hour. We know the distance is 108, but we don't know how long it's going to take. So to work out the time, we'll do 108 divided by 48. Which is 2.25 hours. So that is 2 hours and a quarter of an hour, which is 15 minutes. 0.25 of an hour is 15 minutes. You could do also 0.25 times 60 and it gives you 15 minutes as well. So that's the driving time. We need to add the train, which is 34 minutes, and walk 25 minutes. So if we add these together, so 15 plus 34 plus 25 gives us 74 minutes. So that's more than an hour. So if I take away 60, that gives me 14. So I'm going to carry over an hour here and make this 3 hours and 14 minutes. They need to be at the stadium by 2:30 p.m. So we're going to go 3 hours and 14 minutes backwards. 2 hours first, and that will take us to 12:30 p.m. Another hour, and this will be 11:30 a.m. and now 14 minutes. So taking away 14 from 30 leaves us with 16. So 11:16 a.m. Paul and Fran start the race at the same time. Fran cycles the 60 kilometers at an average speed of 15 miles per hour. Fran completes the race and waits for Paul to finish. Paul finishes the race in 167 minutes. Does Fran wait for more than 10 minutes? Use 1 mile equals 1.6 kilometers. You must show your working. We're given the distance in kilometers and the speed in miles per hour. So we need to either convert the distance or the speed, because they need to be in the same unit, either miles or kilometers. I'm going to convert the kilometers into miles. So 1 mile is equal to 1.6 kilometers. What about 60 kilometers? What's that equal to in miles? So what do we need to multiply 1.6 by to get 60? What I'm going to do is 60 divided by 1.6, which is 37.5. So we'll do this on the other side. 1 times 37.5 is 37.5 miles. So 60 kilometers is equal to 37.5 miles. So let's see how quickly Fran finishes. We've got the formula. Speed is equal to distance over time. We know the speed is 15 miles per hour. The distance in miles is 37.5. We don't know the time. So to work out the time, we'll do 37.5 divided by 15, which is 2.5. 2.5 hours, which is 2.5 hours. So to convert that into minutes, so we can compare it with 167, we can do 2.5 times 60, because there are 60 minutes in 1 hour. And that is 150. So 167 take away 150 gives us 17 minutes. So Fran waited for 17 minutes, which is more than 10 minutes. So we're going to say yes. He waited for 17 minutes. The charity organizes an annual sponsored swim. Ahmed swam 50 lengths of a pole that is 25 meters long. The swim took him 38 minutes. Ahmed says, my average speed was more than 0.7 meters per second. Is Ahmed correct? You must show your working. So he did 50 lengths of a pole that is 25 meters long. So what we're going to do is 50 times 25 to get the total distance. And that is 1,250 meters. And he did that in 38 minutes. So we're using the formula. Speed is equal to distance over time. The speed we're given here is meters per second. So we're going to do the same here so we can compare. So we don't know the speed, we're going to work it out. The distance is in meters, 1,250. Over time, we've got 38 minutes, but we need to convert those into seconds first. So what we're going to do is 38 times 60. Which is 2,280. So now dividing 1,250 by 2,280 gives us 0.548 meters per second. So that is not more than 0.7. So we're going to say no. It was 0.548 meters per second. And this is the end of the questions.